Sorry, all. I'll just quickly review that the link in the discussion group, the page in the discussion group on importing objects into Fusion 360 includes links. A lot of them are 3D surface models. My favorite is GrabCAD, which has sort of open source. You can put your models up there when you're done with them so that other people can use them. And then within Fusion 360, there's Mcmaster and the Parts for CAD. Parts for CAD is primarily manufacturers supplying their models. And it's really more geared at the commercial space than the hobbyist. Okay, I'm going to go to Fusion 360, and I'm going to go, I had mentioned that I'm doing a model of the Ortour. Ooh. And I haven't gotten very far yet, but this is a combination of elements.
So were you able to bring that whole laser in as a component?
Well, I created the extrusion here, but then some of the optics I borrowed from a model I found on GrabCAD.
Huh.
This fan I found on one of the sites. I think this might have actually been Parts for CAD. And then spacers are simple donuts, basically. Those are easier to just make. And then the fasteners, the screws, etc., I brought in from Mcmaster-Carr. And then
did you bring in the right size screws? I mean, are you doing this right to like how it really is?
Pretty close. I'm using my micrometer to check.
So yeah, pretty darn close then. Yeah.
I haven't pulled out a thread gauge to make sure, because there's, for example, the screws that these bearing wheels are on. Yeah. The bearing wheels are 5mm holes. I'm not sure if the screws are actually 5mm. I think they are actually, because they seem 30mm long.
They ought to be for tight control. Yeah.
They might, like, you know, to provide a little play. I wasn't sure if they were like a number 12 or something, something oddball there. Just less than 5mm.
So you faked the laser,
so
except for the optics.
Yeah, the optics I borrowed from. I did find another diode laser device, and I was going to use it, but then the extrusion was different, and the holes were different. So I just went ahead and made my own extrusion here for the body of the laser. But if you look at my browser here, you'll see a couple of interesting things. So the laser carriage is a subassembly, and so this is everything that moves with just the laser itself. And included in this, oh, where's that roller wheel? What's a roller wheel? Hang on.
Hey, Tim,
yep.
As you describe this, could you, when we started this whole series, you talked about your approach to design. Mm-hmm. And I think that as you are talking to us about this, if you're consistent with that, you'd be able to describe how you started from the top down, or whatever the way you described it. That would be helpful for us to hear, to reinforce your philosophy of how you go about doing this.
That's a good point. And in reality, when you're designing something from scratch, it really makes sense to go top down. When you're capturing an existing item, it may or may not make sense.
Got it.
So what I'm doing here is I'm kind of starting with the most mobile sub-assembly, building those components, and then going to the next one. But as I go, I'm thinking through, what should be in a subassembly and what should be separate. So for example,
you talked about this a while ago when you mentioned that you were thinking about doing the OR tour. I remember you held it up and we had a brief conversation about moving parts and subassemblies. Yeah.
So for example, this thing can slide up or down on that mounting plate.
Yeah.
And one of the reasons I'm doing this is because I'd like to design my own mounting plate. I'm not happy with that mounting plate.
Yep.
Yeah.
And I mean, for a $200 device, I can't really complain, but I still want to do something different. And but this slides up and down on the mounting plate. So if I turn the mounting plate on, you can see that it's here, and here are those slots that it can slide up and down on.
Tim, correct me if you're wrong, if I'm wrong, but I think you're saying that when you're designing from scratch, you can apply the philosophy that you described at the outset. But when you're mimicking reality, you're just describing an approach to building up, and you're starting with the moving parts, and you'll progress through somehow. Is that right?
You could do it either way. Like you could start. It would be logical. It would be logical also to start with the non-moving base and build it up, and then build the Y stage, and then the X stage, and then the laser. Part of the reason that I focused on this first is because this is the part I want to do stuff with.
Got it. You just needed to choose an approach, and you just chose that one because you want to make the mounting bracket.
Right. If I don't even get all the way of doing the whole rest of it, at least I'm going to get to the point of modeling this so I can do this, replace the mounting bracket with something I like better.
Got it. Thank you.
Okay, so I think one of the best ways to demonstrate how to do some things like using imported parts is just to do some of it on this model. So I'm going to proceed with this model, and I didn't actually finish the mounting plate. There's a hole missing down here, and then there's a little pad here for touching the limit switch. But I've got these holes in here in roughly the right location, so I basically use my calipers and measure the existing plate and duplicate the geometry here. Now, if I look at my next step, the next obvious thing is this assembly here, which includes the screw, machine screw, the standoff, the wheel, a washer, and a nut on the other side. So I'm going to go through this exercise as part of the class.
Hey, Tim, just out of curiosity, I'm wondering if you could ask how many people on this actually own an auteur, because certain of us are totally familiar with what you're talking about. And I'm just kind of curious if like a lot of us have them or not. You can see everybody's picture in the gallery.
About half the people. Who all has the auteur?
I raised my hand.
Pretty much everybody has a camera on has one.
Yeah, Dallas did. Yeah. Okay. Okay, cool. All right, great. I just was curious. Thanks.
Okay, cool. So basically, the next step, so I'm going to turn on the laser mounting slide platform because that's part of what I'm adding on to. And I'm going to make the laser carriage itself compress that rather than open it. So now what I want to do is I want to get the screw that's going to stick out here. So I'm going to say insert a Mcmaster-Carr component. I'm going to go to screws and bolts, just like I normally use Mcmaster-Carr online. Metric, and some reason or other is still showing me non-metric. So I'm going to go to M5. I'm a big fan of stainless. At this point, I'm not going to worry about the grade, but it's going to be a rounded head. Phillips rounded head, passivated. Length I know is 30 millimeters. And there I am. I've got the 92000A332. And over here where it says product detail in CAD, can everybody see this?
Yeah.
Bit small perhaps on the screen. I go here, it shows me my details, my price, everything else. And at the bottom, actually let me open this picture, this window a little wider. There's a screen. And then here's a 3D download. So I can pick 3D models or drawings. My preference is 3D step. I say save.
And that first time you mentioned CAD, that was just an indication in the UI that if you went into it, you'd be able to find CAD files. Is that right?
That's correct.
Okay.
Okay, so, okay.
This saves it into your cloud storage area?
It actually drops it right into your model.
So into your file, that's your CAD file.
Into your open project that you were in when you went to the insert button.
Okay.
Now, another approach is you can just go to your web browser, go to Mcmaster-Carr, find the model, download it to your computer, and then import it into the model when you're ready. And that's what we'll do with the other websites that aren't integrated into Fusion 360. So I'm going to just move this guy over here. And then I'm going to rotate him so he's in the right orientation for me. Whoops, that should be 90 degrees, not 95. And I'm going to do a shift mouse wheel to go like this. And I'm going to say, okay, for now. Now I have this screw in my design, in my project, but it's not in the right location. So I'm going to use a line in this case. I'm not doing joints or assemblies yet. I'm going to use a line, which is a simpler approach. So a line is in my modify menu.
Not a line, a line.
I had to do a double take too.
Align, yeah. So I'm going to align one surface to another. So in this case, I want to align
the face.
This surface of the screw to, I'm going to hold, click and go down to, oh, come on, this surface of the face.
Oh, wow.
Now it's going to go back there. I'm going to say, okay. Now that,
yep, it's there.
That should have aligned it there. If I, whoops,
hey, that's probably where the other one's supposed to go.
Right.
If I look here, I see that, yes, I got the surfaces I meant to get.
Yeah.
That's nice.
Okay. Now,
did it automatically know that you would be looking for the hole for it to go through?
Not yet.
Or did you
no, it didn't. I have to tell it that.
Okay.
Yeah, there was no hole. He hadn't put in the third hole yet, so it's kind of interesting that it did go where it's going to need to be eventually, probably pretty close.
Well, it dropped it into the origin location.
Oh.
That other hole is centered, so
okay.
at least on the in the one direction that made sense.
Right.
Okay, so now what I'm going to do I'm going to right button click and go up and say repeat align. And in this case, I'm going to see if this works. Sometimes I've had trouble with this. This should work, and it works for me on other programs, but it's been problematic. If I pick this radial geometry to...
So it goes for concentric?
I'm trying to do a concentric here.
Yeah.
Ooh.
Oh my.
The problem is
Changed planes.
it does. Somehow or other, it changes planes on me.
Yeah.
So I think maybe if I did that first.
Right, yeah.
In fact, what I'm going to try and do, I'm going to try and say, okay. I'm experimenting here. I didn't think of this before. What happens if I do that? Where'd it go? I lost it. Let's undo that.
There you go.
No. Okay, so did that work? Hang on.
I'm sorry, so if you are saying to two circles align, it knows that concentric is what it should be going for.
It should.
Okay.
I mean, wait, I did that
that we've
right.
seen in this.
So this guy. No. So the other thing we can do here, which is what I've done up here with these screws, is I'll go in here and I'll construct an axis. Oops. Through this plane.
That's the center point? Center line?
Yeah.
Yep.
Now my screw took off on me.
Oh, there it
I'm
is.
still getting used to
the
this
diode light.
concept of capture position.
Happens to me every time I try to put a screw in something. It just drops out and falls away somewhere.
Okay, so what we're going to do here is I'm going to say an axis, and then when it says some components have been moved, I'm going to say capture position. Now it'll lock this guy to here. I'll create this, okay, and now I don't have a line there anymore, so let me go to modify align, and this time I'm going to align come on. Align this guy.
Actually, Tim, couldn't you have chosen any of those circles that were appearing as you hovered over different parts of the screw head?
It seems to.
I mean, they are all themselves concentric to one another.
They are. So if you look at things like the fillets on the edges and things like that,
Yeah.
it doesn't necessarily work. It'll try and do some odd things. I haven't actually tried that with the axes. It might be fine with the axes. We'll
Okay. Well, this
try
one works,
that.
so great.
Try that with the next one.
Yeah, okay.
So this has worked here. So now what I'm going to do is I'm going to say copy and paste, capture position again. And now I'm going to just move this guy over close. I can move him over on the other side so that I mean, if I know the distance, in theory, I could just say the distance, but I don't like to do it that way.
Right.
So now what I'm going to do is I'm going to construct an axis through this face. Okay. And then I'm going to modify a line, and I'm going to try this circle with this axis. You're right, it worked.
Huh, cool.
Okay. What doesn't work
possible on
sometimes
that
is if you
screw that part that you thought was a diameter, perhaps it was modeled to look like a diameter, but it actually has a slight taper, and it confused the system. Whereas if you just have the ring concentric with the hole made more sense than a slight cone trying to be concentric.
Where the surface of the ring was perpendicular to the surface that it was going to be mounted on. So it didn't have any taper, it didn't have any deflection.
Well, I'm just supposing that that part of the screw that Tim first grabbed,
Yeah.
we all think of it, it's supposed to be a diameter, but perhaps it wasn't a diameter. Perhaps there was a slight taper in it, and that may have confused Fusion 360.
Right.
I'm not sure. I'm just throwing.
Yeah, where I see it get confused, the axis actually is a little more robust. Where I see it get confused is if I grab a cylindrical surface on one part, and then I grab, say, the the filleted area here, that gets it all confused.
Yeah. And maybe that was what Jim was saying, though.
Yeah.
Where it was a taper like that. Because the fillet is a taper, and that it's not one diameter, it is a converging diameter. Anyhow, it worked.
It worked. So now here you see we have these two screws, and they've come in with their Mcmaster-Carr part number. Now, the next thing I have on there is a plastic standoff. Looks a little bit like one of these, but it's slightly different. And I'm just going to model that in place. Excuse me. So I'm going to create a new component. The parent is laser mounting slide platform plate. And I'm going to call this Standoff 9x6 because I measured it earlier.
Where the inner diameter would be that 5 millimeters again?
The inner diameter would be 5 millimeters. The outer diameter is 9, and
Okay.
the standoff amount is 6. So now it's active. So I'm going to create a sketch, and I'm going to use this surface to create it on. And I'm going to sketch a circle here, and that's going to be 9. And I'm going to create another circle. And it's going to be 5. And then I'm going to go to my constraints. I'm going to make sure that these and this, whoops. Well, I wanted that anyways, but I also want this to be concentric to this. Okay, so now I think I'm good. I'm going to finish sketch. I'm going to extrude. I'm going to grab this ring, and I'm going to say 6 millimeters. It's a new body, no taper. Okay. So now, here it is. The problem is it did it in steel. I'm going to modify physical material in this case. I'm going to grab my white acetal, Delrin, and there we go. So there's my standoff. I'm going to save frequently. And then I'm going to copy, and somewhere here I had paste. Oh, I guess I've still selected it, that's why. I go, wait, where's my, can I not paste? Paste. Don't actually
I
see
think
it.
it's again at the core, at the axis.
Doesn't seem to have happened here. Copy. Paste. Why is this not doing a copy paste for me? Where am I?
Could
Let
have
me-
pasted it in identically the same place as the first one?
No, because it would show me there's another one here. I think the reason is because the standoff itself was the active component. So I came up and made the slide platform the active component. Now, I think if I copy and paste, now I got a new one. And yes, it is in exactly the same location.
But where do you see that it's a new one? Oh, right underneath it. Okay, got it.
Right underneath it, right there, colon 2.
Yeah.
So now I'm going to come over here, and I could just offset it by a distance, which is what I'm doing now. But to be sure that I'm following my design intent, I'm going to use an align, and I'm going to align. Come on.
You're going from
Yeah,
the
that
center
should
point?
work to this.
Yep.
Capture position. Okay. Now it's locked in there. So there's my two spacers. Now what's the next thing on here? Then I have a wheel. And it's a bearing wheel. And I don't really want to measure it all and model it, so I'm going to cheat. I'm going to borrow a part. So I'm going to go to my web browser, and I'm going to come over to grabcad.com, and there's all kinds of things in here, and I'm going to do a search on something that gets me there. In this case, I've kind of done a little bit of homework, and I found that somebody had modeled a Creality 3D printer that also has these wheels on it. So right here it is, called the Creality Ender 3 Pro. Now I've logged in. This is a free site. I've registered, have a user ID. I've logged in. I come, I get this guy. I noticed in the, actually I should go back to that, in the description, he said there are step and IGES files and rendering. So these are the file types available. Rendering is just a picture. IGES works, it's primarily a surface model. Step is more robust, so when it's available, I'll go with step. If you look at this one over here, Solidworks Stl Rendering. So with the Pro license, I can import a Solidworks model, but with the hobbyist license, I can't. Now, what I do once I pick this is I could come over here and say, figure out what it is I want to download. So the PNG file, that's going to be a picture. Here's a step file of the filament coil holder. And then here's a step file of the whole thing. And here's a PNG or a picture of the whole thing, a rendering. Now, I already downloaded this. It's a big file, so I downloaded it offline, but it's easy. You just click on it, download it. Now that I've downloaded it onto my hard drive, I'm going to come in here. I'm going to open a new unused window. I'm going to say File, Open, Open from my computer. I'm going to go to my, in this case, I went to something called Outbox, and I have it here, ender3pro.stp that I downloaded. And there's other things in here. Here's the fan that I downloaded earlier. I think this is a stepper motor. I found all this stuff on these various websites.
Hey, Tim, sometimes, actually the vast majority of times when you're using a format that's not native to a program, they use an import function. Is that not true here? Open is just inclusive of native formats and things like step files and...
Yes.
Yes? Okay.
Yeah, you say open for other non-native formats as well.
Okay.
Good point. It's the same as, like, you can do a save as and change the format, or you can do export.
Okay, so export is kind of normal there. Okay, but you can also do a save as. Okay.
You can also do a save as and change the file format. Okay. Now this is a pretty good sized model, so it'll take a little bit of time to come up. Plus with Zoom running and a few other things in the background here,
This is the entire Ender 3 Pro that you're loading?
Yep.
Okay. Hey, Doug, isn't the Ender 3 Pro a pretty popular 3D printer out there?
Oh yeah, very popular.
Yeah.
Yeah, and it does use the exact same wheels. Because when he was having problems, I looked over, tried to find some wheels, and then I looked at the wheels on my Ender.
Oh, you have an Ender?
Yeah.
Oh, okay.
Yeah, I bought one 2 years ago. I just put it together for this COVID stuff, actually.
That's what I,
Good for old projects.
Yep.
Incompleted old projects.
Travis, I have the Ender Pro 3 myself.
Oh, is that right? Okay. Oh, okay. I mean, I've heard of it a lot.
I got it for $112 on a flash sale. I couldn't pass it.
Oh my gosh, that's so inexpensive. Wow.
Yeah, mine was 175.
Wow.
Absolutely couldn't pass it up, and that's why it stayed in the box for 2 years.
Oh, as a kit.
Yeah.
Okay.
It was pretty easy.
Actually, I've been impressed how well it works. I'm not used to the higher class ones, and it does a good job for me.
Great.
Yeah, the i3, which is what the base design is a solid design. That's basically, you can see it right there.
Yeah, it's the classic open source.
It works.
Of course, the interesting thing here is you may have noticed when we looked at it back here, it said by Evgeny. And sure enough, when you come in here,
oh, it's all Russian.
it's in Russian, right? So now I've got this because I might want to steal stepper motors off it, but for now at least, I want these wheels.
So do you suppose that they have the entire wheel as a single component?
Well, let's find out. So I click on this, I click on the wheel, and I see the line come underneath whatever this is attempting to say.
Right.
So I open this, and because it's actually this whole assembly.
Oh my gosh.
Okay, then I'm going to click on this wheel again, and this subassembly is going to highlight. You see the dotted line underneath it, and then I click on this. Aha! That's what I want. So I'm going to isolate. Sure enough, that's my wheel. Now it's probably simple. I doubt that there's ball bearings inside the model. But I'm going to try just copy and paste. Let's see if it works.
Yeah.
I haven't tried this before. Copy.
So
Come
you
over here.
you know from previous that the inner diameter on that is the 5 millimeters you need, or no?
Correct.
Okay.
Okay, did anything paste anywhere? I don't see it.
It looked like you hit copy, not paste.
That's what I was going to say. It looked like the mouse moved and you got copy
Oh,
instead
okay.
of a paste.
So I'm gonna have to move this so I can get past the zoom controls. Let's go back to the Ender 3 Pro. I'm gonna say copy. I know I could do a save copy as, but let's come back here.
Now, before you paste it in, do you want to paste it on a new layer as an entity, or how is that handled?
Well, I'm activated. If you look, laser mounting slide platform is the active subassembly.
So it'll be
Right.
component under
See
that.
where I want it to go.
Got it. Okay.
Okay, I'm not succeeding at this.
Okay.
So what I'm going to do, I'm going to do a save as, save copy as, and I'm going to call this roller.
Did you get to choose the file format, or is it only going to do it in whatever format it was?
It's going to record it in Fusion,
Okay.
I believe. Okay, I'm going to come over here. And now I'm going to say file. Oh wait, can I insert from here? No, I'm going to do,
This will open within this tab, or it will open a new tab?
that's a good question. That's kind of what I'm wondering. How do I bring it into this model?
Makes you want an import function.
That's where I need an import function, exactly.
So when you saved as, Tim, where did you save it to? Usually if you go over that dashboard, you'll find where you saved it. You can just drag it right in.
Oh, good idea.
Yeah, I saved it in here. So here it is.
Oh, yeah.
Drag it. Will it drag in?
What's a dragon? No.
It's not dragging, but let me see here. Now, how do I?
Was there a right click option in the left frame when you were over there, or is there not?
Aha!
Insert.
Good one. You are correct. Okay, I'm going to close this one because it's just a lot of data I don't want. Don't save that. Okay, so when you right click here, you see insert into current design.
Ah, okay.
So thanks, Travis, you nailed it.
Sure.
So we bring that in. It should throw it into the center there.
Excellent.
I'm going to, whoops, I meant to grab this. Whoops, come on. Oh.
Well, it wants to use that axis, doesn't it?
Yeah, I'm trying to do the rotate thing.
Yeah.
Oh, come on.
It has that one axis highlighted, though. Oh, okay, there you go.
Go like this. Grab this.
All right.
90 degrees. Now.
You're going to align again? Is that what you're going to do?
Yeah, I mean, you know, in theory, I can kind of go like this, move it up to here. But in reality, what I'd like to do is do a line so that I get an absolutely accurate alignment. So I'm going to align Oh, come on. I'm going to align this surface. Oh, come on. Oops. Sorry, there's a little bit of delay here, and so I'm overcompensating.
Hey, Tim, in order for that bearing to work properly, the friction between the standoff and the bearing, the diameters need to, let me say this differently. Your standoff needs to be flush against the inner core of the bearing and not beyond that so that it actually rotates. So I don't know how that bearing functions because I saw an inner ring and an outer ring. Could you go over and hover over the, just outside of the hole? Yeah, there's two. One of those rotates or both of them rotate. I don't know which. And you'd want to have friction. You want to push on that, right? So the diameter of that.
Push on that, correct.
So the diameter of that needs to be your 9, right? 9 millimeters.
You don't want. Well, you want to make sure this isn't rubbing on anything.
Right. I guess it does look a little recessed there, so you're probably okay.
Yeah.
Okay.
I think so. So now you notice I did a modify, but I did 1 and 2 in the wrong order. And even though the others should be locked down, you should align this surface to, come on, come on. Sorry, I'm getting a lot of delay here on what I'm trying to do.
Yeah.
That surface, capture that position, okay. And then I'm going to do right click, repeat align. There's a cylindrical surface and there's a cylindrical surface. See, that doesn't work.
It looks like it's aligned on the center, but it's not on the right surface.
Yeah, when you do the cylindrical surface, it makes the surfaces themselves line up and centers them, and that's not my intent. So what I need to do instead is align the cylinder to the, no, that wasn't what I didn't get what I wanted to get. I want to get the axis. And it's being slow on me.
Did you have that surface before instead of the axis? Is that what you?
Correct. What happened is I got the outer surface and it
Got it.
wasn't what I wanted. Let me try again.
We can see it, you just can't seem to select it. Is that right?
Yeah, it's responding really slowly.
I see. Okay.
Okay, there it is.
Got it.
Okay. And like I did with the other screw, I could just copy that over. I'm not going to do that in the interest of time. Right now, what I'm going to do is I'm going to go find my washer in my screw. Let's see, what's the diameter of my washer? Or my nut, I mean. That's a lock washer. So let's go find, again, we're going to say insert, Mcmaster-Carr component. We're going to go to washers, lock washers, metric split lock washers, standard stainless, M5, And there's only one size really. So let's go with the 316 because it's more expensive. What the heck? And
It's play money.
like detail. Now this might be a little bit of a challenge now that I think about it. I haven't done this one because of course I don't have that nice flat surface.
Or a cylinder, I mean a circle to define.
Yeah. This is gonna be interesting. Let's see what happens. 3D step, save. And here it is. Let's pull it out here somewhere so that we can get in here and have a look. I think actually what I'm going to do in this case, I'm going to
Eyeball it.
eyeball it actually. I mean, I could, in theory, I could create an axis and do the center.
Can you? I mean, I would think you could, but it doesn't have a cylinder. It doesn't have a circle. It doesn't have a thing to say what the center is.
Yeah, I'm not sure if it'd work or not. I'm going to leave a little bit of interference here because it's going to flex.
Yeah.
And I'm going to leave it there. Oh, I said I should have captured position. Let's see, capture position. Okay.
See, that manual placement, now you're doing Travis CAD.
And it's not going to impact anything that happens that we do with this model anyway.
Okay.
Now you insert Mcmaster-Carr, and this time I want a nut, hex nut, and metric.
Looks like you have 10 or 11 of us in the chat. Nuts.
Oh, okay. The chat window. I gotta see where it is. I can't see the chat window. Yeah.
Well, it was a joke. You said you need a nut.
Oh. plenty to spare is what you're telling me. Width, I guess that's the standard. Height, let me have a look at it. That look like 4 millimeters? No, that's not 4 millimeters. That's 2.7. And they're all width 8, so let's go with this guy right here. Product detail. 3D step file. And let's move it over to here somewhere. And
Tim, your goal in doing this is you wanted to redesign that mounting bracket, right?
yeah, I mean, part of it is just for the fun of it. I want to capture a model of the Ortour, and I want to use it for doing some of the assembly and
Oh, that'll be cool. You're going to be able to actually move along the different axes on an Ortour?
Yeah.
Oh, that'll be cool.
Yeah. We'll see how much of it I can really figure out with the belts and everything, but it's,
Right.
It's, it's doable. So let's see here. Let's look at right. And we'll bring this in like this. And then let's look from here. And again, I think I could capture the axis here
Right.
and make it exact. But
It really is an interesting question, though, whether you could do that on that split washer.
yeah, that's a good point. I mean, what are we doing time-wise? 7:30? Let's give it a quick attempt. I'm going to turn off the nut.
I suspect you can do it on the washer because the model of the washer, it probably is a perfect diameter, even though the actual steel washer itself was kind of an upset punch and twisted. So it isn't perfect, but the model I would expect would be a perfect diameter.
It may very well be. Let's see here, modify, align. I want to align.
It looks like a center point, doesn't it?
Come on. Something got selected I didn't want selected. But okay, so let's select. Come on. One of these days I'm gonna have to buy a new computer. Okay, got that.
And a midpoint.
And then let's see, is it gonna let me?
Yeah,
Son of a gun.
perfect.
Let's have a look. See, did it really do it well? It did indeed.
Well, your placement was actually
Good call, Jim.
accurate, but yeah, congratulations. That's great.
So, and then we'll turn this guy back on and we'll save this. And now you'll see that I have two sub-assemblies in my model so far. One is the laser carriage, which is everything that is fixed to the laser carriage. And then I have the laser mounting plate, which eventually will be everything that's fixed to the laser mounting plate. And then some of the stuff I want to play around with when we go to assembly is what happens with the cable when it moves. If I do the cable, I can do the cable using, I think there's a piping module.
Oh my gosh.
Or is there a piping module here? Yeah, there's pipe. And I'm wondering if I can make that dynamic or not. That'll be a test. I'm sure it'll grind to a halt on my computer, but.
Use the pipe function as the means by which you create a belt.
Oh, no, this is for the wire, not for the belt.
For the
cable.
wire.
The electrical,
cable. Got it.
the electrical cables,
Got
I'll
it.
model them as pipes.
And how about the belt?
The belt is going to be a challenge. There is a model. There is a model as part of the training.
Or maybe the ender has a belt.
Yeah, but the problem with the ender is that's a step file. I don't have. That's not a Fusion 360 model. So it's a solid. It's a frozen assembly.
Oh, I see. Okay. Okay. So if you're going to do dynamic builds, you need to have built them within Fusion in order for them to have the ability to add joints or make them into joints or other functioning components?
The elements that are going to be dynamic, certainly, you're going to have to define. If something's
Okay.
going to bend or move,
Okay.
it's going to have to.
Okay. And so you thought we could do that in Fusion with the belt?
I'm going to find out. I'm not. I think there is a way. There's certainly a way to do a rotating belt, but
So I guess
that belt that actually moves with the geometry the belt moves. It'll be
Yeah.
interesting to see how that can be modeled.
Well, what do you think will happen first? Do you think you'll find the answer to whether you can do a belt in Fusion, or your hair gets long enough that you could put it into a pony? Which happens first?
Fair question. Fair question. Speaking of questions, are there any other questions on these import tools and the things that we've done tonight?
Well, I have a question, Tim. Back when we were wondering about the bolt not fitting, is there an easy way just to measure something to see if it is what the diameter is and if it really is a diameter? either on that washer or that bolt? Is there a quick measure tool?
Inspection.
Yeah, under inspect, there's a measure tool. So, for example, if I grab this, it's going to tell me it has a radius 4.5, a diameter of 9, and it gives me the area. And I'm not exactly sure what the loop length is, unless it's let's see, 2 pi or pi d 3. Nope, I'm not sure what that loop length is. It's not the circumference. But let's see, what if I come in really close here? Can I get a surface here? Yeah, that gives me the diameter of 5 on that thread.
Huh.
Now the washer I made 5. It should probably be like 5.2 or something, but you know, you get the idea.
Okay, thanks.
You're welcome. Any other questions?
I have one just because when I teach classes that have to do with vector files, I sort of talk in terms of a hierarchy of preferability. So say start with a DXF, and yet it's preferable to have an SVG over a DXF. Over that, it's preferable to have an AI over the other two. When it comes to these 3D CAD files, as you look at them, you keep coming back to STEP. Are there the most preferred file formats for CAD definition that you carry the most attributes forward and are just most useful because they have more information in them?
So in 3D solids modeling, I find STEP of the more common ones. There are some less common ones that we're not seeing that wouldn't come into Fusion 360 anyway. But with now we're going to have a professional license at the office, right?
As soon as anybody can go to the office, yeah.
So in that case, you could bring in a SolidWorks model or a Pro Engineer model or one of those. And
Pro Engineer is a file format?
Well, it's PRT, and SolidWorks is SLD PRT.
Okay.
Solid part or solid assembly. And if you bring in a model from one of those parametric modeling systems, you're actually going to get features in a timeline.
Oh, really?
That you can
that
deal
carries
with
in?
and you can edit.
Oh, wow, that's powerful.
Yeah. So I haven't done it yet. I do want to try that. Then the next preferable to me is the STEP file. As a solid file format, it seems to be very robust. I never have things fail. I never have one-sided edges or
But no timeline.
seams and stuff like that. Whereas with IGES is sometimes a surface model, and it can have some places where the surfaces don't properly close once you import them. So my hierarchy of preference is STEP first, IGES second, and then something like STL is my least favorite because you know I'm getting a huge file with a lot of points and a triangular approximation of a surface.
But you started with your hierarchy at the top being STEP. It sounded as though the SolidWorks file was actually even better than that.
It is, yeah. If you can get a true 3D file, a true parametric 3D file, that's better because now you have history.
And that was only in the SolidWorks format.
Yeah, let's see here, what can we import? If we say file, open, and open from my computer. Now, all supported files.
Oh, there we go. Okay, that's a dummy file.
Files are typically 2 or 2.5D.
Yeah.
IGES, as indicated, are often surface files. OBJ, we know, are a lot like STL. Step I've talked about, and STL files, and then 123D files.
Yeah, that's another Autodesk file format.
Yeah, I'm less familiar with it.
Well, they actually discontinued that series, so I'm not sure. I guess it's maybe to bring in old files from the day when that program suite was available.
Could be, yeah. Of these, my favorite would be Step.
Yeah, so we don't see any SolidWorks in there.
We don't here now. Where I thought I saw it earlier. What was it? How did I see that? File. Maybe upload. No. Let's try it. Select files.
Yeah.
All files. Ah, here we go.
Oh my goodness! Wow. Okay.
This is a much more comprehensive list. I know I found it somewhere.
But wait, Tim. The difference between what you did before and now was here you are uploading to their cloud storage. It sounds like.
Correct.
And before you were importing directly into the program.
Correct.
Okay.
So it allows us to upload these to the data portal, but we need the professional model to actually use them. The professional version, the pro version of the software to use a lot of them.
And so you see your SolidWorks in there? Yep, sure enough. Part assembly. Yeah. Yep.
NX is another 3D modeler. Parasolid is one that I didn't expect to see here. It's also pretty robust. I've never used it much for import, but some of the tool makers, some of the mold makers I've used have asked for this. They've said sometimes it's actually more stable than Step, depending on a CAD. I think maybe, or sorry, CAM. I think some of the CAM models like Parasolid better.
Boy, Tim, you know, if what you want to do with Fusion 360 is at least in an important way import files from other sources, the pro version really expands your options, doesn't it?
It does for sure, especially if you want to then go in and edit features. Because if you bring these in, it's my understanding that, like I said, I haven't done it yet, but it's my understanding that you get the history tree. You get the history along the bottom, you get features that you can then go in and edit.
Wow.
Which is very powerful.
Very impressive.
Yeah.
Okay, thank you.
Cool.
Phew.
Anybody else got questions, or is anybody ready to do a little show and tell?
I'll do a little show and tell if you want.
Sure.
I have a question whenever we have a minute.
Sure, let's go with the questions first.
Go Lem.
Have you guys covered two-sided machining or multi-sided machining, which you quite often have to do if you're making some part on a CNC and you've only got a 3-axis machine, you need to often turn it over and machine it from the bottom, maintaining registration when doing so. So have you covered that, or do you plan to cover that?
I haven't covered it. I would guess that those of you who use the machines, the milling machines and the routers probably understand that better than I do. I would tend to use some kind of a fixture with alignment features that I can replicate. But that's, you know, that's a statement from a high level point of view. I haven't done it.
Yeah, what I've seen on some YouTube guys, they use pegs, like they drill some holes for pegs in the part, the board that they're going to be machining.
Yep.
And then they also drill pegs into a waste board.
Yeah.
And so that way, when you flip it over, if you drill the pegs with Fusion 360, you know exactly where they are. So when you flip it over, you maintain the registration.
So
I'm a little bit confused about how do you handle the origin whenever you flip it.
So Lem, let me just tell you from a VCarve Pro two-sided milling operation, what some of the pieces are that are missing from what you said. Yes, pegs for alignment, 3D object within a piece of stock where you actually cut a plane through the middle that defines the flipping point. So that, let's assume it's a midpoint, you would on the one side choose perhaps the surface of the material, and then when you flip it, you choose the surface of the bed as your 0. So in your mind's eye, there is a consistency in the logic from one side to the next. That is, the alignment pins keep your X and Y together. Your Z is kept intact because you have a decided approach of starting on the surface of the material on one side and starting on the bed on the other side. And lastly, you choose to split your 3D model within the stock along the midpoint so that it's symmetrical. You're cutting equal depths on both sides. So at a high level, that's kind of the concept. And inside of VCarve, it's a pretty easy to implement approach. And I know you've been listening to videos from what you just said, but there are a couple of projects on the VCarve tutorials in the Vectric site, and I would recommend I'll send you a link for it, or I'll put it into the chat when I find it. There are these pull toys that I've made through a tutorial there, and it is in that tutorial where they do a very nice job of describing, at least with VCarve, how you'd go about doing it. And I suspect that the logic that's there is probably something we could transfer to Fusion, only because it's a reasonable logical approach. So I'll try to find that video for you, and I'll drop it in the chat in just a minute here, okay?
Okay, what I've understood from watching Fusion videos about this is they use a different setup for each side. So you would use one setup in the manufacturing tab for the top side, say, and then you have a second setup for the bottom side.
Yes, you do. You can export obviously completely different G-code files, and you look at them as though they're two different jobs that happen to be tied together through the logic of that pin indexing and the mid material plane that you're using as your flipping point. But again, this particular video, and I only say it from having not only watched it, but then done it, this one particular video is pretty good at getting that across. So again, I'll drop it into the chat in just a second here.
Okay, well, I look forward to viewing it. Thanks for that.
You're welcome.
Okay, any other questions?
Not right now. Still listening.
Okay, let me give Howard control here.
Oh, that's scary.
Oh,
Thanks. Oops. Howard, are you there?
yeah, I'm here.
Okay. Okay, I think I gave it to you. Ah, there we go.
So this is the new dust shoe that I'm trying. I just printed it all up on the 3D printer. And of course, this part right here, that's where your air hose hooks. This part here, that's what goes on your router, your spindle. And then the magnets, there's magnets here and 4 here.
Oh.
And this will click into that. And then the brushes are hooked onto another separate thing. So you could have different length of brushes, coming off of this. And this just hooks onto the bottom. So if you had a big long bit, you could have brushes that are 3 inches long. But if you have like a short bit, you could have a brush that's only 1 inch long. And so it's not, getting all mushed down in the way.
Howard, we're seeing underneath your part on the left, that's just a shadow, correct, underneath it?
Yes.
Whereas the piece that is the second, where one is atop the other, the one that your cursor is on right now,
Yeah.
that one is where you have the brushes mounted into?
No, well, yeah. The brushes mount to the, there's 4 magnets underneath this body here.
Yeah, yeah.
And these 4 magnets go up there, and the brush comes off the bottom side.
Yeah, that's what I meant to ask. Yeah, so it's actually protruding down from that second.
That section there.
Got it. Okay.
And so one of the advantages, the guy that designed this, he was saying, yeah, you could make 3 or 4 of these with brushes. And so I've already thought, well, why do I want 3 or 4 with brushes? I'll make one with about an inch brush, and I'm just going to make spacers. And that way I can get exactly where I need to go and only have one with the brushes. And
Howard, the answer is for at least a second length, so that if you do have a lot of play and you're going to go you're going to have a lot of Z travel, and you want your bristles to be able to bend a lot, that would be the reason for much longer bristles, is if you really wanted them to be able to bend, because this looks as though it moves with the head. Is that correct? This brush system moves with the Z-axis up and down, correct?
It does, yes.
Okay. Whereas the ones that we've been using, at least in the shop, etc., they stay fixed position so the bristles touch the top surface of the milled material. And so we don't have to worry about long or short brushes there. But when you're starting up at, say, 3.5 inches and you're working down, you would probably want long bristles so that you actually weren't doing good suction in the beginning. And when you got down close to the bed, they bent enough that you were still getting good suction.
Well, I'm real interested in putting the meter on this to see if it increases suction or decreases suction, because you're coming down here, and then your force is coming through this channel, but you got a smaller area around the tool for it to suck. And watching his video, I mean, there wasn't a piece escaping. Like normally when you go to the edge of the board, because you got that big extra piece of brush, it blows out.
Yeah.
Whereas on his video, nothing blew out of there. And like I said, I 3D printed it, about 22 hours of print time.
Howard, I gotta tell you.
Would you run into the possibility of overrunning your brushes and carving into the brush?
No, because I would make sure that if I knew I had a 3D item and it was going to be, an inch of play, I'm going to make sure whatever brush or thing I put in there, would be adequate. I'll probably have more than one brush, but
you have some animation there, so you're on the animation tab.
Oh, I am on the animation tab. I haven't figured out how to do it other than I'm moving the box up here in the corner.
I see.
But yeah, that's what I'm going to learn next, is how do I animate my drawings and separate them. I was happy just to get them apart.
So you guys use the Suck-It brush system at the shop, right?
Yes, we do. Yeah.
That guy is splitting off. He's going off to start some competing company to Carbide 3D.
Yeah, I just saw that. I wasn't sure whether he was starting it up or he had found somebody to partner with. But when you go to their URL now, it does take you to that alternate CNC build option. Maybe he did that out of frustration that Carbide 3D came up with their own vacuum boot. Hey, Howard, I got to tell you, my favorite part of this last 10 minutes has been when you said, I can't wait to put a meter on this thing and measure the suction. I love being a part of a community that has that kind of a technical geek bent. Well done, sir.
Well, I want my system to suck, and I want it to suck hard.
Good geek humor too, Howard.
The only time when you can use that word in a good way.
That's right.
Here's one of my spacers I'm 3D printing right as we have the
Oh,
meeting.
yes.
So anyhow, I'll turn it back over to you.
Okie dokie.
There you go. You back?
Okay, anybody else have anything to show us? Any demos?
That was great, Howard. Thank you.
You're welcome.
Yeah, it was neat for everybody to see that. If there's nobody else, then I think we'll call it, and then we'll see you guys in 2 weeks.
Okay.
So what's the date again on that so I could set it up? It's the 11th, is that right?
July 6th.
I think it's the 6th.
July 6th. Okay, great. I'll set it up for
Very
you.
much, Tim.
Tim, as always, man, thank you very much.
Thank you.
Thanks, everybody. Appreciate the feedback
Thank you.
and the questions and the extra demo, Howard. And you guys take care. We'll see you soon.
Good stuff. Thank you.
You bet. Bye-bye.